All right. So I've got the notes up on my screen. I'm going to put the link in the chat again. So welcome everybody. We're doing the last chapter, lesson 22 in our SQL book. And we're also going to supplement that with a discussion about CTEs and Temp Tables. So welcome. All right. The last lesson in our book is titled Understanding Advanced SQL Features. I don't know if advanced is really the best way to describe this, but basically they're talking about some database features in terms of how databases work, but it really isn't, these topics really aren't directly related to writing queries, okay? So in terms of what you need to know as a data scientist or machine learning person, what you might expect to see in an interview, I don't think that these are really pertinent. So I'm going to go through the material, but one thing you'll notice is I actually purposefully didn't even bother showing you the exact syntax for these commands because I just don't think it's that important. You can certainly look them up. They're in the book. You can look them up online, but I just wanted to cover the concepts and not spend as much time going through them. Okay. So one of the topics we're talking about is constraints. Okay. And constraints are how, primarily we're talking here about relational databases. But constraints are how the database has rules about what is valid data. And the database is going to enforce these rules, okay? So you can, in your application, have whatever things that you want to do. You can say that nobody under 18 is allowed to use your application, so their birthday must be after this date, or sorry, before this date. And that's all well and good, but the database isn't necessarily going to enforce that. But the constraints we're going to talk about are things that you're going to ask the database to enforce. And if somebody tries to insert or update or in some way put data into the system that doesn't meet your criteria, that query is actually going to generate an error message and it's going to fail. So examples are, we're going to go into it, primary and foreign key constraints manage referential integrity. And these kinds of rules, like I said, they are enforced by the database, and it doesn't matter what you're doing. So it's not just when you first insert the data. It's also if you try to do an update and you change something, or if you try to do a delete, if that somehow violates some rule, that will also generate an error message. And so the book does note that, unfortunately, many aspects of how constraints are implemented, what kinds of constraints are allowed, sometimes the syntax a little bit, is vendor specific. So how you do it on SQL Server versus Oracle versus Postgres might be slightly different. So that's a little bit of a pain in the neck. Another reason why I'm not bothering necessarily to show you guys exact examples of the syntax. So let's go through a few of the constraints that are available in most relational databases. So the first is primary keys. Okay, so these are the unique IDs defined for each row. And so technically you can have multiple columns defined to be your primary key. So for example, you could say that I have a table with counties, and I'm going to have state and county, that combination of the two of them, be the unique primary key for that table. So that's a good thing because there are multiple counties of the same name that are in different states. So if you just said county name was going to be your primary key, you would have a problem because you're going to have duplicates. All right. Generally speaking, that's not really considered best practice. That's not very common. So typically you're going to see only a single column being the primary key. And it's generally going to be a numeric value, not a string or other data type. So you want it to be something that's as short and as dense as possible. Some other rules, generally primary keys cannot be null. I'm not sure if the various database systems enforce that rule or not, but you certainly wouldn't expect there to be a row with a null primary key. And also, you wouldn't expect people to modify primary keys, but that doesn't mean that again, the database necessarily will absolutely not allow you to run an update against that column. It'll certainly prevent you from creating duplicates by running updates, but I don't know that just by virtue of like order ID being the primary key on the order table, that means that any update that tries to change that column is going to automatically. And it's also general practice that, let's say you are just using a sequence of numbers that just go 1, 2, 3, 4, 5, 6, and those are your order IDs. That even if you deleted order ID 5, you're never going to go back and reuse 5. You're just going to have a hole in your number. You're going to have orders 1, 2, 3, 4, then you're going to have order 6, and then all the new orders are just still going to be higher numbers. You're never going to go back and reuse number 5. Again, I'm not 100% sure that the different implementations enforce any of these rules, but this is definitely best practice, kind of, what you would typically expect from people. And so again, when you're defining a table, you say create table, you give the name of the table, and you're going to list all the columns. So next to a given column name, you can say primary key, and then the database will know that this column is a primary key. And that one thing that all the systems are going to enforce is they will not allow duplicates. So if you already have an order number 17, there is no way you can insert a new order and say it's order number 17. All right, that's primary keys. Any questions? Anything else you guys want to just discuss before we move on? All right. So then the next aspect of this is foreign keys. And this is basically where you have data in one table that's pointing at the primary key in another table. So the orders table might have a column called customer ID, and it's pointing to the customers table. So the logic here that I have written, down here is that if you declare a column as a foreign key, then you have to say what table and column it's pointing to. Okay. And so basically what the database is going to do is to make sure that if you want customer ID 10 to be in a particular order, there has to be a row in the customers table with ID 10. If not, you're going to get an error message. And so we haven't really talked about relational database theory and all that stuff, but just briefly, the second bullet talks about the fact that if you had thousands upon thousands of orders, but a lot of repeat customers, it would be very wasteful of disk space if you repeated all the customer information, customer name, customer address, customer phone number, all that stuff. If you repeated that in every order, okay? Instead, what you can do is you can have one row in the customers table that can have lots and lots of information about that customer. And then all you have to do in the orders is say customer 10. So you're just using up one integer, and that's the equivalent of having all that information about the customer, because you can always join to it in order if you want any of that information about that customer. It is typical that a foreign key is not going to allow nulls. So for example, in an order, you would think what's most likely is that it's going to say the customer ID is a required field. It cannot have nulls. But that is not an absolute rule. You can have exceptions. So imagine, for example, you have the employee table and you have a column called who is that employee's manager? Okay. And so employee 5, their manager is employee 2, whatever. When you get to, let's say, maybe the CEO has no manager. They're at the top of the pyramid. And so they might have, for example, a null in the manager field. So it's, again, it's sort of up to the person designing the database whether or not they want to allow that, but it is possible. And then one thing the book does mention, and I wanted to highlight, is that typically what you think about is the case where you're inserting an order and you want to make sure that whatever customer ID you have in that corresponds to a valid row in the customers table. But actually, the reverse situation is true. If you try to delete a row in the customers table, if that customer has any foreign keys pointing to it, so if you try to delete customer 20, if there are orders with customer ID 20, you will get an error message. The database will not allow you to do that. So that's the gist of the foreign keys. And again, the syntax is a little bit more complex than the primary key because you don't just say something is a foreign key. You have to say it's a foreign key and what is the table and the column that it's pointing to. That's my non-technical way of describing it. All right. Any questions about foreign keys? All right. So then we'll move on to two other kinds of constraints. A pretty common one is a unique constraint. There's just many situations that crop up where you expect every single row to have a different value. Primary keys are one place where you expect that, but there are other places. The book said, like, hey, if you have an employee table, maybe you expect all the social security numbers to be different. I don't know if I can think of a great example off the top of my head. Maybe somebody can post one in the chat. But it certainly comes up from time to time. Like, let's say I have a table and I've got geographic information about the different states in the United States, okay? So the primary key might be one thing, but you might have things like postal abbreviations, and then for those people who are familiar, there are FIPS codes, numeric codes that correspond to the states. And so like all of the postal abbreviations and the FIPS codes are also going to be unique for each state, even though they're not the primary key in that table. And then if none of those constraints does the job for you, the advanced systems allow you to do user-defined check constraints. And this is going to be very vendor specific, but generally speaking, you can have some short expression that says that here's the minimum value. So age must be greater than or equal to 0. Or here's the maximum value, percent blah de blah must be less than or equal to 100. And you can even say, I just have here a list of possible values. So for gender, I have 2, 3, 4, whatever, a specific list, M, F, U, whatever. And these are the only values that I want the database to allow the user to store in this particular column. Because if you just say the column is a single character, well, then it'll accept any character. But your check constraint can then enforce that the only values that it will store are, let's say, M, F, and U. All right, and then just to kind of reiterate that if you're running a query that would violate one of these constraints, you will see an error message and your query is going to get canceled. It will not be performed. So it's not that you will get, this is not a warning type situation. This is a hard error type situation. It will say, I refuse to do the query that you asked me to do because it would have violated one of these constraints. All right, that's our section on constraints. Any questions? Okay, so the next topic in this chapter is indexes. So indexes are a tool that databases use to improve the speed of some queries. And so when you have an index, it can really speed up retrieval of data. Generally speaking, retrieval is part of select queries, but like you can imagine that if you're trying to update one particular row, first you need to find that row. And so in fact, having an index might actually speed up an update where you're updating a particular row, something like that. So it's not only speeding up select queries, but for the most part, we think of them like when you just talk colloquially, it's like, oh yeah. Your indexes are going to speed up your selects. The downside of queries is that whenever you modify your data, you also have to update all your indexes. You have to modify them correspondingly. If you delete a bunch of rows, then you have to delete those entries from your index. If you update a bunch of rows and they change, then you need to change what's in your index as well. Same thing for inserts. So the more indexes you have, the more it'll slow down your inserts, updates, and deletes, generally speaking. The other thing about indexes is they can take up quite a bit of disk space. If you're curious as to sort of how they work behind the scenes, you've heard about balance trees. Databases use balance trees to store your data, but they also can use balance trees to store the index keys. And so, for example, if you have last name in your customer table, you can have an index on last name, and it'll sort all the names in this very special balance tree. Instead of a binary tree with two-way branching, it's going to do multi-way branching, and so that is called the B tree. That's the technical name. So just B, the letter B. All right. Another note: not all data can be indexed well. So what you want is data that has high cardinality. There's just a lot of different values, and ideally mostly unique values. So if you had an index, for example, on the state code, that would work really well because every state has a different value. If you had if you had an index on the gender column and it only had 3 possible values, then basically if you have a million rows in your database and there's only 3 unique values, you're going to have this teeny tiny index that isn't really going to help you very much because, half of your entries are M's and half of your entries are F's. And just knowing where the M's are isn't really going to help you because you still have 500,000 M's that are all ties in terms of, going through that index. Another thing that an index can do is if you have a query and you ask to have the data returned sorted, so you have an order by in your select. Well, in certain situations, if you have the index and the index is sorted by that same thing, that can potentially speed things up because instead of the database having to sort your data after it fetches it, it's already sorted in exactly the order you want, and so it can just return it, bam. Let's see here. I will note that you can create indexes over multiple columns. So you can say, I want an index on last name, comma, first name, 2 different columns, and the order matters. So if you say, I want an index on last name, comma, first name, then if you do a search for Smith, comma, John, that's still going to be very fast compared to just looking at all the Smiths because the index will be able to jump you from Smith, A, Smith B, Smith C, all the way directly to Smith John. However, because the ordering matters, if you asked for customers whose first name is John, then an index that is based on last name, comma, first name, that's not going to help you at all. Okay. All right, any other notes here? Other than that, I would just say that index tuning is a pretty advanced topic. Again, it's useful to know what indexes are, so you're just aware, but I don't think that it's an appropriate topic, and I would be very surprised if in any machine learning interview somebody asked you a question about relational database indexing. That just seems wholly inappropriate. One final note is all of this conversation really has been about like the traditional basic kind of an index. And so with that, you can have any kind of simple data that's ordered. So whether it's numbers or strings, we all know how to sort those, although like sorting Unicode strings, by the way, is like a little bit more complicated. But there are other kinds of indexes. So like for geographic data, there are spatial indexes that speed up geographic queries, free text indexes so that you can do certain kinds of like regular expression and other kinds of searches. So, database systems do offer some of these indexes that will help you, work better with XML, JSON, things like that. And things get a little bit more complicated there. But so again, the indexes ultimately will never make a difference in the correctness or whatever of the answers you get. They're just going to change the speed of how fast your query runs. So again, I think not all that pertinent to a machine learning interview. Any questions about indexes? All right. One more topic along these lines. Relational databases allow you to create triggers. So triggers are user SQL code. They're a little bit like stored procedures. But stored procedures, you can have a general purpose function that does anything. Triggers are like stored procedures that get run specifically at the time that a user query, tries to modify a particular table. Okay, and so this allows you to basically write any SQL code you run in order to do a validity check against what's happening. So if you write an insert trigger, okay, then anytime someone tries to insert a row into that particular table, it's going to run your particular SQL code. And so what the SQL code generally would look like is something of the form of, if I see blah, 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 I'm going to raise an error and cancel this query, else do nothing, let it happen just fine. Okay, that's a pretty common kind of trigger that people write. You can do other kinds of things in a trigger. For example, you could log activity if you wanted to. So, different kinds of things. Again, pretty advanced topic. I would say that writing triggers is extremely difficult. You can really accidentally slow down your database a lot by writing triggers. So even for a database administrator, I would say writing triggers is kind of hard, wholly outside the scope of a data science. All right, final topic, they mentioned, hey, you should be aware that there's database security. And so you should just know that there's multiple layers here, right? So you may have access only to certain database servers, and within those servers only to certain databases, and within those databases only to certain tables. And some databases will allow you to even restrict things. For example, I could say, I will allow you to see the customers table, but maybe for whatever reason, you in your role can see XYZ information, but you can't see their personal information. You can't see their address, their email address, their phone number. Okay, because you're supposed to be fulfilling orders, you don't necessarily need that. And so in some systems, you can actually say which columns individual users or roles on the system are allowed to access. You can say whether people have read versus write permission for all of the above. And there is a trick where you can have things that people can access indirectly via a view or stored procedure, but they cannot access directly. So at my prior company, I mentioned that our applications did all access through stored procedures. So there was never a handwritten query in any of the application code. It would simply say, I want to run this stored procedure with this set of parameters, and then that would happen. So if you want to insert a row, it would call the stored procedure that inserts a row and give it all the values. In order to enforce that people use the stored procedures, in fact, they did not have permissions to actually select or insert against any of the tables directly. If they looked at the database, they wouldn't see any tables. All they would see is a list of stored procedures. So they had to go through the stored procedures, which, because of the database security trick, basically you could say this stored procedure has the rights to do certain things that even the user who's calling the stored procedure doesn't have the rights to do. And then finally, there's these terms DML and DDL that database people throw around for data definition language and data modification language. So all the queries we're talking about, select, insert, update, delete, those are data modification queries. Most systems like Microsoft SQL Server, you can say, I'm going to allow this person to do those things, but data definition, creating tables, altering tables, deleting tables, those are functions that are these users are not allowed. So you're allowed to look at the stuff in the tables, but you're not supposed to be changing the structure of the database itself. So these are common things in terms of security. And so probably not an interview question, but certainly if you get a job and then you're trying to do something you may need to just sort of be aware that these kinds of securities, so something could happen depending on the specific vendor's implementation. You may be able to see that there is a table called customers, but that you don't have permission to read it. Okay. Depending on the implementation, you might not even be able to see that that table exists. And so like Bob may say to you, oh, just run a select against the customers table. And you're like, what customers table? So basically this is a way to understand that depending on the implementation, it may just be a permissions thing. And so you need to talk to your security team, your DBA, whatever, and say, hey, I'm told that I need to query the customers table. I don't currently have permission. Can you please fix that? All right. So that's a quick run through of lesson 22. Anything anybody wants to ask about, either about these specific things or something that maybe they think should have been covered in this chapter that we didn't talk about?
I just wanted to know, do we need to know if something is DDL or DML? I mean, do we need to, like, I'm just wondering if that would be a reasonable interview question.
No, I mean, I didn't even put them in the notes, but I threw them out there just out loud so that you're not like, you'll have heard these expressions before. But basically, just know that running a select, insert, update, delete is something that normal level users are allowed to do. But things like creating tables, creating indexes, these are things that usually most normal users don't have permission to do. It takes a certain kind of database administrator who would be given permission to do those DDL, so data definition. So creating the structure of the database generally is only for admins. You're going to typically be limited to just select, insert, update, delete.
Okay, thank you.
Yeah, thanks for the question. Anything else? All right, let's move on to common table expressions. It just takes a little while to say all the syllables, so most people don't say common table expressions. They say CTEs. In the meetup, on the GitHub, I have a link to a page I found online that talks about them. So here's the link right here on some site called learnsql.com. So what is a CTE? So a CTE is a way you can define a temporary result set that you want to use within a single query. You can basically think of it as a subquery that you give a name to, okay? And so if you have a subquery that says, my special subset of the orders, then any place where you can normally use a table name, you can, instead of using a real full database table, you can just say my special subset of orders, and it'll act as if that were a real table. But it's just sort of like a temporary table-like result that you're using just within that one query. Okay, so it's very short-lived. I would say that I thought about this, and anything you can do with a simple single CTE, you could have done it with a subquery instead. And I'm going to show you an example below. When I give you the syntax for CTE, I'm going to show you the exact same query where I just sort of moved the code around a little bit to turn it into a subquery instead of a CTE. So hopefully that will make it very concrete. But I will mention that there are some slightly more advanced things you can do with CTEs. You can have multiple CTEs, and you can even nest them, where CTE1 uses CTE2, which uses CTE3, and that gets a little bit different. So we'll talk about that a little bit later. And there's also this thing, which I don't know if I've ever actually seen it used in real life, but there's this thing for recursive CTEs. I've certainly seen like crazy puzzle questions about how to write a recursive CTE to do some bizarre thing, and that's kind of fun as a puzzle, but I've never seen a production system that used recursive CTEs, so I'm not really going to talk about that. All right, so how do you use a CTE? Basically, at the beginning of your query, you use this special keyword with, okay? And then at the beginning of your query, you write a select statement that says, here's the information that you temporarily want to act like a table. All right, and then throughout your query, you can use it. Once you've defined a CTE at the beginning in that with clause, then you're allowed to use it as many times as you want. You often might only need to use it once, but you certainly can use it a lot. And so, you know, one case that I can think of where this has come up for me, again, is I'm writing a query and it's got a group by and it's got some aggregate functions, and I'm counting this and I'm counting that and I'm counting that. But the user wants to see not just all of these counts, but they want to see how that count is a percentage of the total population. Okay. Generally speaking, it's very hard to know what the total population is when you're doing a certain query and you're doing a group by or whatever. So you need to use a subquery or something to separately calculate that. And so oftentimes I'll have some code where you see like count something times 100 because it's a percentage divided by, and then a subquery that's the total count. And in some cases, I'm repeating this subquery because the total count is the total count. It's the same. But if I have 6 different percentages, I'm dividing by that total count 6 times. In terms of readability, it would be cleaner to define a CTE. It's the total count, and then just, you know, join against that. And then it's very clear that even when you reference it 6 times, it's all referring to the same exact thing. And you don't ever have the risk that, oh my God, I changed my query slightly, but oops, I only changed it in 5 out of the 6 places. So those are some reasons why CTEs just kind of can make for more readable code. All right, so let me pause here and see if there's any questions about sort of this. Maybe I'll show you the syntax in just 1 second. So anything other than that, and then hopefully things will be very concrete once you see the example. All right. So from the web page that we linked, we have this, the formatting. I tabbed things a lot more, and I added a little bit of a where clause just to make it clear where the end of the query is. Okay, so we have with the name of our CTE is called average students. And then we have a select query that is going to return multiple rows potentially. In this case, it is going to return multiple rows because it's going to return 1 row for every district. And then basically, once we have this with clause, we can pretend in the following select statement that there is a table called average students in our database. And in fact, what you'll see here is that we write a select, we have from schools, and then we join with average students. So this is our CTE average students, but we treat it just as if it were any other database in the table. And it will have rows and it will have column names, and we're all set. So in this case, it's sort of like the thing I was saying with percents. They wanted to know what is the average number of students for each district. And they're going to display that in a query that's not grouping by district. This query is going to list each individual school individually. And so if there are 30 schools in a district, it's going to have 30 rows of schools within that district. But each one of them is supposed to show the same number here, which is the average number of students for that particular district. But all the rows for a different district are going to show some other number. So this is a very common use case that you're sort of grouping at 2 different levels in the same query. The main query is just at the 1 row level, but this particular column, you really want information that's grouped at the district level. So this is how you can accomplish that. So if I scroll a little bit, then basically this query, select blah, blah, blah from schools group by district ID. instead of putting it in the with clause, I can just slam it right here where the join was. Okay, so up above I said join average students, but instead of using the CTE, I could have just blasted the code right in here. And this is character for character, letter for letter, word for word, the exact same select that appeared up here in the with. Okay, so really, to a certain extent, it's just a question of style, whether you prefer to have, look, here's one select up top in the with part, and here's a versus here we interrupt in the middle of this main select. Here, right smack dab in the middle of it, I've got a subquery. So I do personally think that for readability, it's a little bit easier to read when this particular select is up top in the with. And so it just gives you, sort of more frequent, smaller chunks. All right, let me pause here. I've said a fair amount about CTEs. Any comments, any questions?
Yeah, I just have a comment. So when I went to a conference, one of the comments that was made was that it's better to write manageable code with CTEs rather than making subqueries. And thank you for the examples, because now it makes sense.
Yeah, I mean, this literally is letter for letter the same subquery. It's just, to me, more readable to have it split out. And if you had multiple CTEs, or if you had this subquery repeated, like I was saying, 6 times, it's just kind of nice to say, okay, I have one average students here, and then I use average students 6 times later. And then I have some other thing, average blah blah, average grades, and whatever, average attendance. I can have as many, different CTEs as I want. But each of them will hopefully be relatively short, and the name will help people understand what is this supposed to be. Any other comments or questions?
So how is a CTE different from a stored procedure?
A CTE is a chunk of code. It's basically a select, which you could have in a stored procedure, okay? But the way CTEs are used, this particular select only lives for the brief period of time when you're running your main query. If you try to do something with something called average students down here below that, SQL Server is going to say, I have nothing named average students. I don't know what you're talking about. Okay. So even if you somehow created a stored procedure that ran this particular select, it would be a permanent database object that lives there for all of eternity until you delete it. Okay. So that's like the big difference. On a smaller note, it's not necessarily easy to call a stored procedure from within your select and whatever. Ultimately, you would end up with some sort of situation where you have this sort of like subquery thing where you're execing a stored procedure slam right in the middle, interrupting the flow of your main query. But the big thing is CTEs are sort of throwaway temporary objects. This average students will not exist as soon as this main select finishes. You don't have to manually delete it. And also, if another user is running queries on your server and they want to call something average students, it's not an issue. Okay, if you created a stored procedure called calc average students and somebody else created a stored procedure called calc average students, there can only be one. And, somebody's going to collide with the other one and whatever. Does that answer your question, Harold?
Yeah.
Okay, cool. Any other questions? All right. I just want to note, I mentioned this before, there's really nothing trickier about it. But you can have as many CTs as you like. So what you do is you just separate them as comma, with commas. So you're going to have multiple CTEs that are just individual off doing their own thing, but it is also legal to have nested CTEs. And so I didn't write a full query. I just gave you a little bit of a pseudocode outline here. But imagine you said with, and you define CTE1 as some select statement. Then you say comma CTE2. At this point, sure, you can reference all the regular database tables in your database, but you can also at this point say from CTE1. And then if I defined comma CTE3, I could use either CTE1 or CTE2 in it. And so in this sense, I don't know if it seems different to you guys or not, but it, it is a little bit more complicated because these are not, if these were completely independent, then it wouldn't matter what order I define them. But in this case, since CTE2 uses the first one, it has to be defined after CTE1. Okay. Actually, I'm not even sure. I take that back. I'm not sure if the database cares what order you define them, but I always do that. If I'm going to use one inside two, then I certainly always define one first and then two. But maybe technically that's not required, depending on your vendor. Okay, so so you could imagine a scenario where people talk about like data pipelines. Okay, so I didn't get a chance to read the full text, but I saw Ian had a comment in the chat. And if you imagine a data pipeline, you could imagine having a series of CTEs where you say, the first CTE is going to select something, and then the second one is going to do something to it. Like maybe it's going to change the date format. And then you could define a third CTE that takes the output from the second CTE and does something else. And so in that sense, it can kind of help you organize your thoughts. It may not be the absolute fastest code, to run, but in terms of correctness, you could imagine I'm going to find a CTE that instead of boiling the ocean, just kind of gets me this one thing. And then I'm going to do something else that, filters it down, formats it to something, calculates some sum, whatever, that kind of a thing. And then finally, you have some main select that kind of puts together, the pieces. All right, just a couple notes about CTEs. I say that, one of the primary benefits is that it makes your code more readable compared to other options. Like we talked about, hey, could you create a stored procedure? These temporary results disappear as soon as your query is done. And so, so you don't have to manually delete things, when you're done. I will say on a practical level, at the present time on Microsoft SQL Server, I do not use CTEs, okay? Enough people have complained that when you use CTEs, sometimes the performance is garbage, that we've all become gun shy and we just don't use CTEs at all. I'm sure if it's not already fixed relatively quickly in some future version of Microsoft SQL Server, that'll be fixed, and so that won't be. But just know that as with anything in an interview, if you say, look, I'm just writing you, I'm in a pressure situation here and I've got limited time to answer your questions, so I'm writing you, a query for correctness, I'm not necessarily saying that this is the fastest running query that'll do the job. And so if somebody asks you about it, it's okay, I think, for you to say, I'm not sure, I would have to test to see whether this is as fast as you not using a CTE or using some other approach. Generally speaking, I would not expect a machine learning interview to be talking about query performance. So if you can get correctness without doing something sort of weird, like, if there's something you can do in a 5-line query and you wrote 40 lines of SQL to get it done in the most bizarre fashion, even if that actually returned the correct answer 100% of the time, I might as an interviewer, be a little bit concerned. But if you write a nice, pretty readable CTE, to do something, I can't imagine somebody's going to say, oh, by the way, do you know if that's going to run 10% faster or slower than some other way? That seems very weird. All right. I've got 5 minutes left, so I want to move on to temporary tables, but let me just check and see if there are any questions about the CTEs. All right. Okay. So there's not too much more to talk about. Here's the link that I found that does a little bit of an introduction to temp tables. So now that we've talked about CTEs, we have most of the concepts for understanding temp tables. Okay, and by the way, the full name is temporary tables. Again, just to save syllables, everybody I know just says temp tables. So temp tables also, again, store some temporary data. But the key difference is that you can use this temporary result set across multiple queries. Okay, so the CTE, if it's defined at the beginning of a select, as soon as that select is done, it's gone. If you create a temp table and then you run a select against it, temp table is still there. You can run 10 select statements, temp table is still there. So that's one of the big differences in terms of using temp tables. So compared to, again, creating a store procedure or regular table, the big difference is that if you did one of those things, you would have to clean up after yourself. You would have to delete it when you're done. Temp tables do automatically go away, but they don't go away after a single query. They go away when you close your connection. So depending on kind of your application structure, for many of them, the connection will get closed automatically sort of after each thing that you do. And if that's the case, then you don't really need to worry about it. You create a bunch of temp tables and then they will just magically disappear. The database will take care of them for you. If you are in a system where the application flow is such that they reuse that one connection for many, many different operations, then that's a case where I do actually have code where I manually delete temp tables. So I'll create a temp table, I'll run multiple queries that utilize it, and then I will have a statement that says drop table temp blah, blah, blah. Any questions so far?
Are the values in temporary table locked, or they synchronized all the time with original tables?
So let me just say that the way temporary tables worked is with a naming convention. So they have to begin with the hash symbol. Okay, so a table called orders is an ordinary table, and a table called hash orders is a temp table. And so it's not possible to have a temp table with the same name as a regular table. Was that related to your question, or was there something else to it that I missed?
No, I mean that SQL tables are living thing. They may change while we work with them. This was my question. So,
Yes. So because temp tables are tracked and associated unique to your connection, it's not really possible for somebody else to change your temp table because they can't see it. You can only see your temp table in your one connection. Okay. So, so you absolutely are allowed to change what's in your temp table. Okay. And that's, in fact, one of the main reasons why I use temp tables is because I want to go through a series of pipeline steps where I have loaded some data into it, and then I'm going to further modify it or further filter it or append to it or whatever. I'm going to keep changing it through a set of steps, and I'm going to reuse it in other, in other queries and other joins, things like that. A very common situation for me is I'm doing some kind of patient stuff. Okay, and so I will create a temp table that has a list of patients that meet some very complicated criteria that the particular situation calls for. And then I will do a whole series of queries of saying, hey, what are the diagnoses for this list of patients? So I'll do an inner join against that temp table with the patient IDs. And then, hey, what are the procedures for these people? Hey, what are the lab results for these people? So I'm going to run a whole bunch of different queries. And in each case, I'm just going to inner join against my temp table that has my list of patient IDs. So that's like a really, really common use case for me. And so, sure, I could have done it with a subquery, but I would have had to repeat the subquery over and over again. But in this case, I just have that one temp table. I can refer to it over and over again. Did that answer your question? Or I'm looking at the chat. Maybe I didn't get to the point of your question.
Yes, as Ian said, I was wondering if temporary table is static or they're synchronized with original tables.
So you need to explicitly put the data into your temporary tables, okay? So you either need to say create table, like temporary orders, and then say insert into temporary orders some data that you want. Or I'm pretty fond of the special construct where you say select into such and such a table where blah, 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 right? But you have to explicitly put the data into your temp tables. So if you're asking like, do you define some temp table and it just sort of lives there as this static object? No, okay? So when you start a new database connection, you connect to the server, there are no temp tables. You have to make your temp tables, you have to put the data into them, and when you disconnect from the database, it'll say, oh, Maya's gone, and it will just remove all of those temp tables. And nobody else who's using the database can see your temp tables, even if they use the same exact name. The system behind the scenes will magically append hidden characters to the name of your table so that they're all unique. Does that make sense?
Yes.
Okay. Okay, great. So if you have a very simple scenario where you just have one temp table, you insert some data, you could have done that with a subquery. But again, the big difference is that you can use the data in the temp table in multiple queries. All right. Otherwise, you would have had to copy the same subquery or the same CTE into multiple queries. And when you do that, most database systems are nowhere near smart enough to know that that's the same exact thing. So it's actually going to be taking the time to rerun that query over and over and over and over again. Occasionally, I will have a query that is so large, so complex that it's joining 15 tables, and my poor database system has trouble understanding the query. And so when it tries to optimize it to find a fast way to do it, it doesn't actually find sort of the optimal way of doing it. And so it's rare, but in a case like that, if you break it up into smaller chunks, then basically you can sort of force the system to say, hey, I want you to first join these 5 tables, and then I'm going to store the results into temporary table number 1. Then I'm going to join on that with 5 more tables. I'm going to store that in temporary table number 2. And then I'm going to want you to join that with 5 more tables. And then I'm going to have my final result. In that way, you're sort of forcing the database in what order to consider those tables, because it's going to join them, the first 5 that you specified, has to do it in that order. It's not common, for big commercial systems, I find that the query optimizers are very good. But again, I have run into situations where talking about a very large number of large tables where specific parts of the where clause filter down that large table into a smaller number of rows. And so if I know that and I force it to sort of do it in that order, it might be worried that that's a bad way to do it because I'm going to have a lot of rows. But I know, no, that where clause is actually going to do a good job, and the temp table is going to be reasonably small, and then we can go from there to the next thing and so on. So that is a use case. Again, probably not all that relevant for just like a data science interview, but I will also note that when you're debugging your code, you can inspect the contents of your temp table. So if you join for the first 5 tables and you store it in a temp table 1, you can just sit there and you run selects and you can see how many rows are in there and what are they and this and that and that. If you have a CTE, you really can't know what is in that CTE because it's gone as soon as the query is done. What you can do is you can copy and paste it and run it separately just to see, you know, what it is. But within the running of your query, you can't actually do that. And so finally, I just wanted to show, like, you know, again, this is sort of skeleton-y pseudocode, but you can imagine that I create a table and it's some table that is special and has some subset of the orders. And I can do things like I can insert into it. I can then update some of the values in it. I can delete a subset of the rows. I can insert some more rows. And then finally, I'm going to run my main select against this temp table that in whatever 4 or 5 steps I've built up. You cannot do sort of literally this with subqueries or CTEs. If these were all selects, maybe you could do it with subqueries or CTEs, but in this case, I'm running inserts, updates, deletes, and you can't run an update or a delete against a CTE. So when I'm doing exploratory data analysis, if I'm doing early stuff on the SQL Server before I've sort of moved my result set onto Python or R, oftentimes I am creating some temp tables to kind of hold things, like I said, my patients of interest, my this of interest or whatever, things like that. And then I can fine tune it. So let's say I say, oh, I think I want to look at like 1,000 patients. Let me see all the people with diabetes. I get 50,000. I was like, oh, that was way more than I needed. And so then I could do something. I could say, just limit it to the first 1,000 rows, or I could say, oh, since I got so many, I'm going to be choosy. Give me only the people who live in California. And then that might be about 1,000 rows, you know, but it just allows me to kind of like, you know, play around with things. And if some of these queries take a while, then once I've run my 2-minute query to get just my 1,000 patients that live in California, now it's super fast because this temp table only has 1,000 rows and I can reuse it over and over and over and over again and not have to go back to the original big table where all the data came from. All right, so that is temp tables. Any questions about temp tables and the flow with that? All right, cool. So we are actually a little over time. We're past the bottom of the hour. We had a sample problem that I gave before Thanksgiving. And so if any people want to stick around, I can also talk about the sample query. But otherwise, we'll sort of stop the recording here and end the official part of tonight's meetup.